Good evening to all. Today we'll be talking about the map visualization techniques. Basically, we'll be discussing about the different map making process, and along with that also we'll see the 3D analysis, how it is being carried out. Currently, the map visualization process is one of the important activity in GIS. So we'll see what are the importance of those. So before starting it, let's have a look of a good map. Generally, any kind of GIS information system, at the end of the total processing activity, we need to generate some kind of map. So those maps can either be a web-based map or it can be a paper-based traditional map. Under the web-based map, what happens is that we will be having the important thematic layer. Along with that, we'll also have a few of the in the paper-based map, we have the actual thematic informations. Along with that, we also have some other information like legend, the north arrows keys. There will also be a bar, the scale bar, which will giving the scale of the maps. In case of web-based maps, the thematic map is being provided, and the scale bars is also being provided in the visual screen. In this case, in case of web-based map, what happens is that the information is being presented at multi-scale. So user has an ability to interact with the web-based interfaces, and based on that, the scale gets adjusted. So in this, why it is called a good map? The information presented in this is quite nicely been put into different themes, and there's also different legends is being provided. So in the cases whenever user wants to have additional informations, they can refer to these informations in the map and can get details. Now let's have a look of the bad maps. Now why this is called a bad maps? Again, the geo information is present in this like this picture also, but the information is being represented in this case is not visible. As you can see that the number of points which is being represented over here is very large, and as an end user will hardly be able to distinguish what exactly the cartographer or the map maker wants to convey in this. In such cases, whenever we want to put a large number of informations in a map, then we should do a process called generalization process, and then only we should represent it in an appropriate way. Otherwise, if you have a data set like this, at the end of the day, even if after doing a lot of processing, the information presented is not going to convey any informations, then in that case, the visualization process, in that case, the total effort of GIS information system goes in vain. So now let's discuss why we need a map. Generally, we create a maps to understand an effective way of geographical data. Most of the time, as an end users or as an analyst, we will be interested in to find out what are the spatial patterns in different geographical processes, what are the relationship, what are the trends between them. On the screen, as you see that there is a map of Dehradun. Now, there is a specific characteristic of this map. Why does this map or the city is spread like this? There are a lot of questions can be asked, like what are the connectivity roads? If you see that the roads connectivity is again going along the river lines. So there is a specific pattern relationship which is being observed in this map, and we can investigate why such kind of relationship exists in a specific map. So to do that, and generally the maps will have a few or the three important criteria using which the information can be provided. One of them is that where. That is actually related to a geographical context which gives the information where exactly a particular phenomenon is going to occur. And such as in this case, as you see in the screen, it's basically a maximum surface temperature across the whole India is being shown. So if somebody is interested to find out where exactly is the temperature at 30 degrees centigrade in this map. So this gives an idea about what are the places where the such information or such temperature is existing. We can also do a reverse query like where we want to know what are the geographical contexts where specific phenomenon is having a specific attribute. For example, we'll be interested in what is the northwest, or what is the temperature at Rajasthan, what is the temperature at a specific district of or maybe at a specific state of an India, let's say Tamil Nadu. So in such cases, it provides a kind of information where and what, and generally there is a temporal information is also being added into a map, which gives a kind of linear trend in a temporal domain. So if you have informations of the same place at different instances, then we can also create a maps to understand how temporally the specific phenomenon is related. So this also helps in to find out the temporal relationship between temporal and spatio-temporal relationship between the features. So we can see that the map is actually consists of three different vertex of a triangle, that is what, when, and where. Generally, the thematic attributes which will be linked to what, so either we'll be interested in a specific theme, for example, the forest cover, or maybe a temperature, or a sea surface temperature, or pressure, any thematic attribute is possible. Generally, these thematic attributes get linked to specific geographical locations. So the geographical location actually provides a specific boundaries. Generally, it will be having some kind of administrative boundaries, and will also have an additional vertex in a triangle is called time. So combining these three different vertex of a data space, we can create a different kind of maps. In any map, the most important thing which is required is a topographic informations. We can have a different kind of maps, for example, the temperature map. But temperature map is a kind of continuous field in a specific domain or a specific area. But most of the time we'll be interested in to link it back to some of the geographical features. So topographic map generally helps in that. Topographic map will have few of the important features like display surface features, for example, road, lakes, rivers. Generally, these will be, it will contain man-made features, which is important, and which will also have a larger existence on the surface, on the Earth surfaces. So this can be a crossing between crossing points. It can also have different road networks, junctions, and along with that, there are important features like rivers. There is also some cultural features like important monuments. Along with that, the topographic maps will also have some kind of grid systems, which gives the important line or the sections in a map, which tells what exactly is the lat-long values. So whenever we have these information represented in topographic maps, it gets overlaid onto the top of any thematic maps, and that when it gets combined, the themes gets associated with specific features. And these thematic maps or the information will generally be dependent upon the map scale. So information which will be represented at 1:50,000 or 1:25,000 will be slightly different. And the importance of topographic base map is it helps to associate the phenomenon to a specific geographical locations. Actually, topographic maps are the important features or the important component of a map, which helps to link it to any specific thematic features back to geographical systems. So now let's come to what exactly a good map is made of. Generally, the good map has a lot of questionnaires which needs to be put in, and all these questions answers gives the specific informations about what exactly what is going to make a good map. Generally, we have to say, like, whenever we want to create a map or any information which we want to convey to end users, so we need to just first make sure ourselves what exactly we want to represent. We may be having a map or the geographical information in a large areas and multiple themes may be there. For example, we may have a road network, we may have different residential area, we may have a district boundaries, we may have different water bodies, or there are kind of multiple line polygons will be represented in a different themes which is present on the Earth surface that may be presented to us. But in most of the cases, we'll be interested in to find out why there is what is the purpose and what we want to represent. So let's say I am interested to or let's say I want to study that how the different the density or the density of residential density is represented in a specific city. So in that case, the other features like forest area or agriculture may not be important. So in such cases, our motive is only to represent the residential area in a specific city, and that becomes an important factor. So we can say that our purpose is being to represent only the residential area. We also need to make into the consideration who is going to read those maps and where this map will be used for. So these, according to that, the informations can be represented in a specific map. So this actually governs the different audience. So that's what we call it, the audience or the for whom we want to prepare the informations. Then there may be sometimes cases where the different information may not be present. For example, if you want to represent information at 1:10,000 scale road networks, but data availability of that scale may not be there. So in such cases, we need to consider what are the information available to us and what those are the constraints. Along with that, we also need to understand what are the resources available in terms of time and equipments where we want to represent these informations. So generally, time and equipments will come to the external factor which helps or which governs the map design processes. And finally, whenever we have decided our intent and the user whom we want to represent the information, along with all the information which we have collected, we are going to put it in a specific pattern or in a specific manner so that it conveys a specific meaning or the meaning which we want to represent to an audience. So those meaningful representation of the geographical information actually is being governed by a cartographic design principles. So that actually helps into how it is going to be represented, and generally it will have a kind of experimental activities. So in any kind of map designing or a map creation process, that is actually called the cartography, where we'll be having a large amount of geographical data, and that goes through a visual process where, as we discussed in the previous slide, where we have to say what are the informations and for whom, what are the constraints which we want to represent, what are the constraints, what are the information is available to us, and those after selecting those, then we are left with the effective way of representations in a specific map, in an effective representation of informations in form of maps. So visualization process generally helps basically helps to a cartographer to just answer questions whatever is being asked in a previous slide, that how do I say and what to whom and is it effective way of doing this. So this can also be considered in an elaborate form, that what means the cartographic informations. So all the information which you have collected, and those information, how are going to represent in a different specific symbols and signs. So there are few important map elements or the different components of the map is presented, which we have to represent in a form of map. And then those information again goes to a specific user. Sometime we may have a user who is going to evaluate those relationship or the map representation which we have put in. And then again, if if there is any change or any requirement where the user wants to say or make some changes into that, so as a cartographer we make those changes, and accordingly again the whole process starts. So under the visualization process, we have a few cartographic informations which gets converted into a map using cartographic science systems to the end users, and then finally the end users does some kind of evaluations to the map. In case of GIS systems, we'll be having a geo database, and that database will actually determine what are the scales. So if you're having a map which has been digitized from, let's say, 1:50,000 scale, so the geographical data whatever we are having is 1:50,000. So if somebody wants to represent a map at 1:10,000, that may not be possible. So the geodata will determine what exactly is the scale, and based on that scales we will be having all those features and the corresponding visual perception of those variables. For example, if you're having a map at 1:50,000 and this map is being represents the different water bodies, so we can say that if he wants to represent, or if somebody at the end user if wants to see water bodies, he or she will be interested to see some kind of blue color. So there is a kind of perceptions properties is being assigned to those visual variables, and finally there is those features again gets classified and put into a different visual variables to map back to a specific map, which again can go into a geodatabase. Sometimes this process may also require a kind of generalization process, where such the cases where we may have a geodata set which is at the larger scale. For example, my geodatabase may be at 1:10,000 and we have to represent the information at 1:50,000. So in such cases we have to make some kind of transformation of all those detailed features available into a perceptual sections, and then again that will get mapped to a visual variables. So under the visualization process, again the geodata becomes an important input along with the measurement scale, which actually determines the other processes like the generalization processes or the representation process, selection processes that gets linked into the cases. We will not be talking about the generalization process in today's lectures. So in today's lecture, we are just going to restrict to ourselves to only the map designing or the map production process. Under the map production process, each of those map actually requires a kind of design. So as any other the processes, especially either technical or non-technical processes, there will be a few steps or the few guidelines needs to be followed. Same is also applicable to the visualization processes. So under the visualization processes, there's a need to have a design. That design basically are required for making a professional looking maps, and then finally following few of the map design principles, and it also requires some kind of cartographic knowledge, especially the uses of different color combinations. So to create an effective map design, we need to consider few of the basically there needs to follow some kind of conventions. So generally those conventions is being followed based on the different visual grammar and structures. So those are actually a cartographic grammars and structure is being defined, and we need to understand those, and then we can go for, we can come up with this, the best design which is possible using the cartographic principles. There's also few cartographic conventions, as for example, the forest needs to be represented into green, same way it applies to the water bodies. The agriculture land will be represented in yellow color. Most of the time the man-made features, especially the residential areas will be represented in the red color. Road networks are generally being represented, or any kind of connectivity network will be represented in terms of black colors. So such kind of cartographic conventions we also need to consider while creating an effective map design. So all this helps us to create an effective map designs. So during the map representation, especially for the thematic map, there's an important factor which comes to represent the data in summarized form. So generally there may be cases where we may have a very large data set might be there. For example, if we may have population density map of entire different districts of India. So in such cases, there are hundreds of districts present in India. So if I represent a map giving all the details on individual details, the density of each of those districts, then the end users will not have patience enough to see all 600 and different some odd number in the maps to come to the conclusion, okay, what exactly is the density of different districts. So generally what happens is, in a map, we go for a kind of summarizations, and that summarization actually helps us to reduce the number of information or the information burden to the end users, and it also helps us to do the summarization of total processes, total data sets. So the thematic map generally will have to deal with such kind of information. So there may be an accurately underlying data sets. Sometimes we also need to do some kind of generalizations. So there will always be, as a cartographer or as a map designer, we will be having such kind of constraint or which we have to deal with that. There may be cases to represent that. So we'll see a few of those cases and how we're going to create it. So generally, most of the time, or the most important questions which we deal with, that how many classes should we go for? If we have very less number of classes, then the information gets completely summarized, and the variability across in the data patterns cannot be seen. At the same time, if we have very large number of data set classified, in such cases, the number of information which will be represented will be very large, and then it will be very difficult for end users to assimilate the information. So generally, the cartographic principle says that if you are having an information, then we should restrict our classes to 5 to 6. But in some cases, we can go till 8 or around 9 or 10. But in any cases, the number of classes we should not exceed more than 16. Because there are the reasons for that. There is a specific, like if you have the larger number of variables or the larger number of information being represented, then as a human being, it's very difficult to assimilate the information. In such cases, we have to go for a summarized kind of information. So in such cases, there are wide variety of doing a classifications of the data sets or the summarizations. So most of the time will be either a manually or the equal interval. So it means like the data sets being collected, and then we are going to create, or we're going to create sub interval to represent the classes. So equal interval, natural break, quartiles, as well as standard deviations. There are actually ways to, there are reasons for selecting these classes. For example, if you want to, if you're having some kind of poverty elevation indexes, or maybe we can say that we may be having an average income in a specific state. Now, if I want to see that is there any disparity in a state in terms of average income, and let's say we are having a data set for different districts or villages. In such cases, the standard deviation classifications can help to find out how much there's a deviations between actual data sets or the actual average which is being reported, along with that the minimum and maximum possibility. So if we create a map like that, then it can give us a kind of idea where exactly is there the pattern or the average income of state is equally distributed or not, or it is specifically clustered. In cases of, let's say, we are having a data set where we are having different classes. For example, if somebody asks like, what exactly is the per capita income or the customer wants to spend on a specific weekend. So there may be cases of the different users at all different age groups. So at the children's, or they may be an adolescent, or the people who are as the completely adult, and then senior citizens. So the patterns or the expense that each of those categories is going to make will have a kind of breaks. So natural breaks actually helps in identifying those groups. So it's basically being used to identify from a specific data sets. If you are interested to identify any subgroups, then natural breaks helps in finding that. And based on that, again, we can do the classifications of the data sets. The equal interval are basically useful to identify, or let's say that if we are interested to do a comparison of different regions. For example, let's say that we want to see, okay, first 5 days of each month, we are interested to find out how much money is going to be spent by a specific customers. In such cases, month-wise equal interval. So the data set, maybe we may be having 365 days, but we can do a division of every 30 bin size. And again, we can do a selection of only 5 days from that. So which gives an idea of average variation or the seasonal variation of the income in a specific zone. So there are actually the data sets which helps, there are the data sets which can be classified depending upon its purpose. We can use any one of the listed techniques. Generally, in most of the default cases, generally we go for a natural break or a quartile. So that's the classification scheme which we use it. Now let's see what is the impact of that in a map visualization processes. This shows basically a map of Dehradun ward where we are having a different populations. So there are the number of the population numbers is being represented into this. Now as you can see that in case of equal interval cases, the data sets is being represented in 4 different classes. Now, if I see the complete area of this whole map, the information from the different wards in a map in outer area of the city, it's very difficult to differentiate between those, because the larger number of classes, or the classes actually each of those classes is getting classified into 1 and 2 classes only. The larger variability is getting lost in such case, in this case. Now let's say we go for a quantile based classifications. Now in this case we are seeing that the statistical distributions of the population is being clearly depicted in this slide. So from these, not only at the center of this or the center of this map, but along with that, the periphery, as we move from center to the periphery, then the population is also going decreasing, and that variability is clearly understood or has come up nicely in this case. Now, if you say go for a natural break again, we can see that there is a break at different intervals which is being represented. So there are few cases where the population density, the number of the population is being represented at the center, but as you move away, the number of population in a specific ward is again coming down. So such kind of variability is being shown in this case, and this can link to an effective growth of the city. Like if, for example, the core of this map may show that what exactly is where are the places where the old Dehradun is there and how it is growing. So such kind of informations can be represented or can be investigated whenever we do a kind of natural breaks kind of classifications. In case of standard deviations, which says that how the population is varying across different wards, again at the center we see the large number of the population is, or the information is highly dominated at center, but as you move away from the periphery, the information also, or also getting into lower scales. So that is also being shown. So the same data sets, but a different kind of classifications map, classifying those data sets give different representation of the information. So if you want to represent the population of Dehradun, different wards of Dehradun city, then in such cases what we need to always consider is that what we want to intend to represent, or what exactly we want to convey. That we have to consider while creating thematic maps. So the map, as I discussed earlier, that the map designing is actually the different components or the elements of map which are going to represent, and all these component actually needs to be put into a pleasing, using the pleasing design processes in aesthetically manner, and generally it also being governed by a few principles. For example, simplicity and appropriateness. Appropriateness comes from the functional context. In this case, like you see that there are three different contexts is being shown in these maps. One is the hospital accessibility from different residential area that is being shown. The other places are different vegetations available around the city. And third one is the different connectivity and the different tourist place available in Dehradun. So depending upon the kind of map or the information which we want to represent to the end users, the corresponding informations we can select it. And this is the first steps in selecting the appropriate data sets for map designing. Then we go for a pleasing appearance, like we may have two different classes which can be represented with the different patterns. In this case, we are seeing that there are two different polygons. Each of those polygons is being represented differently with a different shades of color. In same case is we can also differentiate between two data sets using an appropriate density or taking into the consideration of the usage. Sometimes we can also use the different data variables to define those density. So density maps can be created. And we can also use the different contrast with the same patterns. So that's the another important factor, like proportion, harmony of different features along with the different contrast colors helps in to decide or helps to make good and appropriate maps. The maps also gets affected by some of the external controls or the factors. So the map purpose is the most important factor. So if the end user is not interested in the details what he wants to represent, for example, if the tourist map is being represented, so he or she may not be interested what are the areas where it's been covered by a forest, or what are the areas which is having an agriculture land. So that's the first important factor, like those are what we call the external factors. The topics of the map or the scales, basically it's also an important factor as we discussed, along with the page layout. This page layout actually decides that what kind of features we want to represent. Is the information is going to be represented on a computer screen, or it going to be represented in a paper map? Again, the size of those paper maps. Nowadays, we are also talking about the maps is being displayed or is being put into a mobiles. So in such cases, the map generation process also needs to be modified. For example, in case of mobile-based maps, we may not have the north arrow keys. We may only show one specific attribute, for example, only the road networks, and the other information may be provided as and when required. In case of computer screen map or in the paper-based map, we have to consider the color combinations. So in case of RGB, color combination is good for online screen or the screen display cases, but for the cases where we want to represent the map in a form of papers, then the colors combinations will different. So we have to use the YUMCV combinations of the colors to represent the maps. So these are the factors which actually helps in which governs the map design processes. So map design processes also sometimes called is more of factor or it's basically is being governed by the creativity. There's also an visualizations which again needs to be taken into consideration, like the proper arrangement of different elements, the legends, maybe put it at the left hand side or the right hand side, the representation of different layout or the different titles can also be put in. So there's a way to there is actually experimental ways to play around with those map elements and then come up with appropriate visualization of the thematic data so that we can have a specific harmony and the clarity of the information which we want to represent. As we said that there are few map elements or the components which is part of any map design. So generally the four important map elements like the base, symbolization, title and legend, which we can find it in any of the available maps. And the base or symbols which is being represented and which actually takes the larger area of any maps are actually a soul of maps. The base map actually helps us to identify or link any kind of thematic map back to a geographical area. And symbols are basically an important factor to link back to a specific subject matter. For example, if you want to show an hospital or if you want to show the different airports, so appropriate symbol has to be chosen. So these are actually the base and the different symbols which are actually being used are actually an important factor in any of the maps. And after that, the layout or the way this information is being represented. Again, it's being as we said that it's basically is being governed by the map design processes. So in case of map element representations, there are a lot of different factors are there, but one of the important factor which is there is that there is a visual ordering of map elements has to be considered. There are generally two forms of visual ordering. One is called the planar organization, another is called hierarchical organizations. So the planar or hierarchical organizations is actually the thematic symbols. It's related to thematic symbol, how we are going to represent it. It's linked to that. So under the planar organizations, again, there's two sub categories which needs to be considered. One is the visual balance. So it means like the different map elements, how we are going to place it in appropriate map layout. And then we are also going to say that how much spaces which we are going to give. What are the important that again can be put in as on the kind of the information we want to represent, and again it's also it will be dependent upon what are the information is available to us. So based on that, giving the priority importance, we can do or we can provide a different information in a map layouts, and accordingly the division of space can be put in. There's also a way to relatively give importance to one features to the another features, and that can be represented. In planar organization, generally also we need to make sure that whenever any users wants to get or reach that maps, the information needs to be represented in such a way that the information looks or the map thematic information is inputted at the optical center of the maps. We also need to consider the natural eye organizations, which again is an important factor to do the different placement of the elements. So this just shows that how the optical center and the geometrical center are linked. Generally, whenever we see any kind of maps, the important or the important component of map, the theme or symbol which is being represented at the center, will not exactly be at the optical center, but there will be a slight offset, generally 5 to 10% of the offset will be there. That's because that's called the optical center. So as a human being, whenever we want to do a focus, whenever we do a focus to a specific symmetrical geometry, then the optical center will always be slightly above the geometrical center. So this factor also needs to be considered while creating a paper-based map. We also need to consider the planar organization. So as we do an activity on or any information is being put in front of any human beings, generally there will be an eye movement which will be from the top left corner. There will be an entry, and the correspondingly the right bottom corner there will be exit of eye movements. This actually applies to any kind of information. So even if you do searching on Google or if you're looking at informations, so that's always there will be movement from top left to right bottoms. So this also needs to be considered into a map layout. For example, if you want to put a legend, so generally we should try to put a legend at the bottom right, so that whenever a user sees the central theme of the maps, he can then later on, while exiting the from the fringe, he can see the additional information regarding the maps. One of the important factor which we need to consider is in a planar organization is the figure ground contrast. Now these two maps is being shown over here. Now as you can see in the left hand side of the maps, the boundaries has been represented, but the total ward or the total number of different wards which is being represented in this case is not coming out from the background. Why? Because the background color is a white, as well as the different fill color of these wards are also white. So a first instant of the look, immediately it becomes it's not that it is not that evident that you want to differentiate the wards from the background. Where in case of the gray color combinations, all the wards comes out separately from the background, and the user gets immediate attention to only to the maps. The other white information or the information which is being represented is not being the user is not putting the attention in that case. So the user is only having full attention to all the wards which is being represented over here. So this is how the use of better contrast can help us to differentiate between the foreground maps along with the background. The another example of foreground or background contrast is being shown in this case. Now, in both the maps actually represents the similar informations. Like we are having an background, Dehradun wards is being represented, along with the ward boundaries and different road networks is being shown. But in case of the right hand side of the maps, as we see, the ward boundaries gets easily differentiated with respect to the different roads which is being shown over here. So what is happening in this case is that with the help of better line contrast, we can emphasize or we can help in to differentiate or get focus only to ward boundaries rather than the road network. Such kind of using an appropriate contrast can help and get a focus on specific subjects for the or specific subjects to the of audience. Along with these visual contrast, there is also other few cartographic tools like hue, intensity, and saturation. So these are actually also called the dimension of colors. Hue is nothing but the different colors which is possible. Intensity is the variation of the same colors, where saturation is basically talking about that how the color is getting from impure to purity. So the purity of color is being put into saturation. So these three dimensions can also help since to to differentiate different classes of a thematic map. Hues are generally being used in the cases where we may have a data set in form of categorical data sets. For example, we want to show all the different wards of Dehradun. So in that case, one ward may not be having a hierarchy, or we may not be considered to be at higher or elevated position compared to the other wards. In such cases, all the wards are equally important, and we need to differentiate between those two wards. So hue can be an important factor which can help us to differentiate that. In some cases, what may happen is that we may have a similar continuous data sets which we want to differentiate. For example, population density. So population density at a specific area may be from 0 to any numbers. So in such cases, the difference or these scales, the variation of the scale gets mapped to a color variations from lighter to darker or darker to lighter, and based on that the color is being assigned to a specific polygons or line or point. So whenever we are having an continuous data sets, or maybe there's an ordinality in data sets, in such cases the intensity or saturations can be used to differentiate the different classes. Apart from the colors combinations, the usage of contrast, there is also an important attributes which needs to be considered while creating an effective map. That is the placement of labels. Again, while creating a map or putting the different symbols, this is again an important factor which needs to be taken into considerations. Like there are ways to represent the different point or a line or area, and there's also a legend how we're going to represent it. So we'll see all of them one by one. So in the cases wherever we are having a points, we need to consider few of the important factors. For example, the name of ports and harbor towns place seawards. It's one of the important factor which goes in any kind of professional map. So if you see a professional map being published by any mapping agency of any country, all the ports and harbor towns will be placed in seaward. The reason for that is can be considered is that the ports are actually being considered will have some kind of water or extension of the ocean. So that's why all the ports and harbor will be put it towards seawards. Same way, if in the cases of river, the city is not sitting or coming, will be placed on the top of water body. Instead of that, the city will be having at the bank of rivers. So in such cases, the city names needs to be placed towards the land side of the polygons or the areas. That needs to be that has to be considered while placing that. In the same way, also the coastline or the river names should not overlap. So these are the few things which we should consider while labeling the point data sets. In case of labeling a linear features, for example, road networks or the river or the stream or the highway road, generally what happens is these features, labeling is being done along the features. So what it means is that if the feature is being in a straight line, then labeling can also be put in a straight line. In case of feature being in curvy, so accordingly the placement of those level features also needs to be placed in a simplified curvature manners. And for the name of important river bodies, generally it will be put into italics. So that also needs to be considered. One of the important labeling placement for the linear feature is that the text should not cross the linear feature. So it will be along, or it will be just running side by side, but it will never cross the linear features or the linear feature wherever we want to represent it. In case of labeling of areas, generally the labels will be put at the center of the polygons, and such polygons can be an oceans or bay or any large lake, country, state, counties, and so on. So few of the example of placement of linear features is being shown in this case. Let's say, for example, the different ways of representing a text placement. So in one case, the text placement is slightly above the point data sets. Another is the cases where just on the top of the point data sets, the feature has been represented over here. Same way along the at just right hand side or the left hand side. So the placement of this text can be put in any one of those formats. Generally, if you want to represent capitals of a city or maybe a country, capital of a state or a city or a capital of a country, generally this particular placement is being preferred. In case of linear features, we can go along the linear features. We should not place it on the top of the linear features. We can also have a placement of different polygons. So these polygons will again be placed inside the polygons, and again it can be used in italics or any other formats can be used based on the conventions. The another important area in a map where we put text are actually titles. So the title will have, or it's actually the most important text which is being put in a map. It gives a brief summary of what exactly as a map maker you want to represent, and it will be most dominant text in all map. Sometimes it may be cases that the title may not have all the information which you want to represent. So the important part goes in the part of title, and then there may be a subtitle associated with that. So that can also be put in, which will be having a smaller font, and generally it goes at the bottom of the main title. We can also place the title boxes and the corresponding different titles can be put in. There are different formats. So any kind of the map making GIS software will allow to do customization of all these text placement. So text placement can be a legend or legend text placement or a title or maybe different features. So it allows to use or change those features. So a professional looking map will have a visibility, or it will look like something of this sort. This is a relief map which is being generated. So the different relief or the height is being shown in this map. The corresponding labeling is being put it on the left hand side of this. The ocean's color, as you can see, is being put into italics and curvy features. That is being put in this case. So these then scale bar is also being put at the bottom to give the information about at what scale this map is being generated. The different theme colors or the classes based on the class data classifications, the relief map is being represented as a theme of this map. So any professional map should have, or the map which will follow a particular cartographic design principle will look like something of this sort. So it takes care of the placement of ports, cities, like if you see the different ports, the placement of cities or the rivers, you see over here that any city which is being sitting at the bank of rivers, those are not being put it onto the top of or crossing the linear features. So any cartographic design, cartographically designed map should take care of all these important aspects of map making. Now we'll come to a next topic, that is the 3D analysis, which is actually again the geographical information which is represented in 3D format, and that can be put it in form of 3D visualizations can be used to display those. So generally the question is being asked is that what are the advantage of having an 3D visualizations or the 3D GIS visualization of those maps. Now there are additional analysis or GIS analysis which can be carried out based on the 3D analysis map visualizations. For example, in this case, if we are having a different vertical extension of urban areas, and if at a particular place I want to know that what are the different visible areas on the ground from a specific place. So this kind of analysis, that is called the viewshed analysis, 3D viewshed analysis, can be carried out in this case. So if you see wherever the green color is being represented, so all those areas are visible from this point, and all the other areas where the red color is there, those are actually obscured just behind the another tall buildings. So this is an example of where 3D analysis can be carried out to find out, or 3D visualizations can be helpful in doing 3D analysis. The same extension of the 3D analysis is being shown in this visualizations, where not only the ground visibility, but along with that, the surface visibility of different buildings is also being shown in over here. So that's the additional extension of the 3D analysis. This is another area, this is another example of 3D analysis where as we move progress, so it's like we want to do a kind of analysis, the shadow analysis if you want to do it. So if at a particular geographical location, if you want to find out how in a day the shadows is going to fall from one building to another building. Such kind of analysis is possible with the help of 3D visualizations. In this case, we can do studies to find out the potential, solar potential of a specific building, which can be used again, which can be used for creating an basically the green buildings creations can be made on the basis of that. There can be also a way finding from root network finding from specific locations. Consider all the different 3D constraints. So there may be cases where in between we may have multiple obstructions. So how we're going to take it, what is the additional time, taking the horizontal and vertical distances can also be considered in this case. Thus, the 3D analysis can also be do for planning purposes, where we can say at any specific locations or the meeting point can be put in an appropriate maps or 3D maps, and then detailed planning can be put in, can also be used. The additional attribute information of the buildings can also be put in, and can also help to do some kind of analysis. For example, if any municipal area, if they want to do to find out or estimate the total cost of painting all the buildings with a specific color. So in such cases, we want to find out what are the specific area, what are the locations, what are the importance of those detailed informations. So those can be collected from the metadata and can be shown, and along with that the total surface area computations can also be done. This is the shadow analysis. So depending upon the day time, the time of a day, the length of the shadows can be shown. So this again gives the example where the 3D analysis is being can be useful for finding out the shadow analysis. In some cases, especially in 3D analysis, is that we want to find out what is the effective threat domes. That's another important 3D analysis factors. So this becomes an important measurement in case of disaster recovery. Let's say, for example, at a specific locations, if you have any kind of explosion, so what are the areas which will get impacted under that explosion if you want to find out. So that can be analyzed with this 3D analysis and visualizations. The different perspective views can be seen for an area, given a different look of an area, which can help since to do an annotations or an annotations. We can put a different annotations to 3D visualizations, which helps to find out a corresponding layout design of whole cities. So that's kind of, in case of planning, it can also be used. So these are the few examples where we have seen a proper map making processes, and also the uses of different 3D map visualizations and techniques for doing some kind of 3D activity or 3D GIS activity.